In this video, we'll learn about solving quadratic equations. First, you're going to learn some vocabulary, the definition of a quadratic equation. We're going to look at the standard form of a quadratic equation. We're going to learn what it means when we talk about roots of an equation or zeros of a function. And we'll look at two methods of solving quadratic equations, graphing and using square roots. Vocabulary. A quadratic equation in standard form is ax squared plus bx plus c equals 0. And the equals 0 is important for a quadratic equation. The values of x that make the equation true are called the roots of the equation, and they're also called the solutions of the quadratic equation. We've already seen quadratic functions. A quadratic function in standard form is ax squared plus bx plus c equals y. And finding the zeros of the quadratic function means finding the values of x that make y equal to 0. And if you look carefully, you'll notice that those two things really mean the same thing. Solving the quadratic equation is the same thing as finding the zeros of the quadratic function. So in your textbook and in our discussions, we will use the terms finding roots and finding zeros, finding solutions as equivalent terms. First, solving by graphing. The zeros of a quadratic function, ax squared plus bx plus c equals y, are the values of x that make y equal to 0. And that probably sounds familiar because that's exactly the definition of the x-intercepts. The x-intercepts are the values of x that make y equal to 0. So to solve the quadratic equation ax squared plus bx plus c equals 0, or to find the roots of the zeros of the quadratic function, we graph the quadratic function and then estimate what the x-intercepts are. So let's take a look at the first one on the left. X squared plus 2x minus 3 equals 0. You see the graph, and you see that there are two x-intercepts, one at -3 and the other at x equals 1. So those are the two solutions of this quadratic equation, x equals 3 or 1. In the middle graph, the graph of x squared plus 2x plus 1 equals 0, you'll notice that there is only one x-intercept, and that is at x equals -1. So this quadratic equation has one solution, x equals -1. Finally, if you look at the graph on the right, x squared plus 3x plus 3 equals 0, you will notice that the graph doesn't cross the x-axis. There are no x-intercepts, so in this case there is no solution. Those are the three possibilities when you are solving a quadratic equation. You'll either get two solutions, one solution, or no solution. Now, I'd like you to solve each of these equations using the graphs provided. And you can assume that each of the boxes on the graph, the lattice, each box is equal to 1 unit. And I'd like you to estimate the solutions, stop the video, estimate the solutions, and then restart the video to find the answers. Okay, so let's take a look. If you look at the first graph on the left, the x-intercepts are -6 and 1, so those are the solutions. And if you actually substitute -6 and 1 into that equation, you'll find that those are the solutions. For -x squared minus 2x plus 3 equals 0, you'll notice that the graph opens down. But we can still see the x-intercepts are -3 and 1, so those are the solutions. And finally, for x squared minus 5x plus 7 equals 0, there are no x-intercepts, so there are no solutions. Now I would like you to try solving each one of these. Please stop the video, find the solutions, and then restart it to see the answers. Okay, so let's take a look at the first graph. In the first graph, you'll notice that the x-intercepts don't quite exactly meet at lattice points. So when that happens in your graphs, you may have to estimate what the zeros or the solutions are. And in this case, a good estimate might be x equals negative 1 1/10 or negative 9 1/10. Any estimate close to those when you're graphing would be just fine. The graph of the second one, you can see that it has no solution, and in the third one, you can see that there is just one solution, x equals 5. Now, we're going to look at a second method of solving quadratic equations, and this is specifically useful for quadratic equations where the coefficient of x is equal to 0, so that there is no x term. So those are equations of the form ax squared plus c equals 0. And those are solved really using mostly techniques that we already know. Here's an example. Solve 3x squared minus 27 equals 0. So the first step might be to add 27 to both sides. You get 3x squared equals 27. Next, we can divide both sides by 3 to get x squared equals 9. And then find the square root of each side. And when we square root both sides, we find that there are two solutions possible. X equals positive 3, because 3 squared equals 9, and x equals negative 3, because negative 3 squared also equals 9. The way we indicate that there are two solutions is using that plus or minus sign next to the 3. The plus or minus is shorthand for 3 and negative 3 being solutions. And when you solve, whenever you take the square root of both sides of an equation, one side will need the plus or minus sign. Here's another example. 2x squared minus 16 equals 0. So the first step would be to add 16 to each side. Divide both sides by 2. Square root both sides. And we get that the solution is x equals plus or minus the square root of 8. And if you wish, you can look at that as a decimal and figure out what that is. Here's another example. 5x squared plus 10 equals 0. So we will subtract 10 from both sides, and we'll get 5x squared equals negative 10. And you might already see a problem, but let's divide each side by 5, and you get x squared equals negative 2. And in the real numbers, when you square something, you can never get a negative number. So we would say that this one has no solutions. Now, what I'd like you to do is try these 4 problems, stop the video while you do them, and then restart the video to see the solutions. Okay, here are the solutions. The first one, x equals plus or minus 4, so 4 or negative 4 are solutions. Second one has no solutions. The third one, even though there's a negative 6, when you subtract 24 and divide by negative 6, you get x squared equals 4, which does have a solution. And then finally, the last one, x equals plus or minus 18. Now we can also solve equations that look like this. X plus 5 squared minus 10 equals 15. Some equations do come in that form, and we can use roots to solve them. So if we take the problem x plus 5 squared minus 10 equals 15, and we add 10 to both sides, find the square root of each side, The left side would be x plus 5, that's simply the square root, and then on the right side we have plus or minus 5. Next, we subtract 5 from each side, and we get x equals negative 5 plus or minus 5. Now what that means is that there are two solutions. One of them is negative 5 plus 5, which is 0, and the other solution is x equals negative 5 minus 5, and that would be negative 10. And if you try, you'll see that both of those work. Here's another example. 2 times x minus 7 squared minus 6 equals 0. So we start with the problem, and first we might add 6 to both sides, then divide by 2, and notice how the division works when you divide both sides of an equation like that by 2, and then square root both sides, and we get x minus 7 equals plus or minus square root of 3. Add 7 to each side, and we find that the two solutions are 7 plus or minus the square root of 3. You can write it like that, and if you decide to use a calculator to estimate them, we find that 7 plus the square root of 3 is about 8 7/73, and 7 minus the square root of 3 is about 5 27/100. So, give these equations a try, solve them using the method that we just showed, stop the video while you do that, and then I'll show you all three solutions when you restart. Okay, and here are the solutions. Notice that the third equation, the one on the right, when you subtracted 9 from each side, you get x minus 2 squared equals negative 5. And something squared equals a negative number is an indication that there is no solution. And this ends our video. Thank you.